start with general chemistry. Okay? Yung pharmaceutical chemistry will follow next meeting. Okay, under general chemistry, we'll review the following. So this will be the outline of topics that will be covered. We'll recall about concepts on classification of matter. And there are different ways to classify matter, if you can still recall. We have classification based on constitution, classification based on property of matter. So we'll review all about that. Then we'll also review different theories, also those persons, mga influential persons who contributed a lot in the knowledge of atomic theory and atomic structure. We'll also review naming and writing chemical formulas of inorganic compounds, and then the types of inorganic reactions, how to identify types of inorganic reactions, and how to predict, no, and write chemical equations. Quantum numbers and different concepts related to quantum numbers, the historical development of periodic table, and lastly, molecular geometry and kinetics. Okay. So please bear with me. You can record also at your end. So we'll start with matter. So anything that has mass and volume, that is considered matter. And again, we can classify it based on composition. So kindly write it. Based on composition, you can classify matter into two: a pure substance or a mixture. When you say pure substance, that's a when you say substance, it has a defined or fixed composition. So defined or fixed composition. And then mixture, on the other hand, is already a combination of substances. So if you have, let's say, two or more pure substances that are physically combined, then that will form a mixture. So again, this is combined physically. That's why we can also separate a mixture via physical means. Let's say via boiling, via precipitation, depending on what mixture or what substances contained in that mixture. Okay, so these are the two classification of matter based on constitution or based on composition. Under pure substance, we can further subclassify them into two. We have element. The other one is compound. When you say element, it's a substance considered as one single atom. Okay? One kind of atom present. Or that could occur in a form of, let me change the color. It may occur individually. Let me write it individually or as molecules. So that's the occurrence of an element. It may occur singly or as molecules. When you say molecules, as diatoms, triatoms, etc. As long as seeing its chemical formula, it only contains one element or one atom per se. Good example are the diatoms. Okay, I will share to you the mnemonics, how to easily remember diatomic molecules. Make use of this mnemonics. Have no fear of cold iced beer. Okay, so highlight letter H. Okay, letter H, N, F, letter O, C, I, N, B. So these are the seven important diatomic molecules. The hydrogen, nitrogen gas, fluorine gas, oxygen gas, yan, chlorine gas, iodine gas, and bromine gas. Okay, so the 7 diatomic molecules. Okay, so these are examples of element. Try to read again the definition. It only contains one kind of atom. Only that it occur as molecule, as diatoms. Diatoms. Two atoms of one type. Okay, two atoms of one type or one kind. All right. Other examples are the monoatoms. Example, mga metals. Example, sodium metal, copper metal, and calcium, so on and so forth. Those are examples of element. On the other hand, when we combine two or more different atoms, two or more different kinds of atoms, then that forms a compound already. And I believe you have encountered a lot of compounds already and you have knowledge. If I will ask you now, example of compound. So water is a very good example, and other compounds that you have learned in your basic chemistry, then those are examples of compound. Okay, try to check water. It has two different atoms present, hydrogen and oxygen. Okay, salt. What else? Vinegar. The vinegar that composed of carbon and oxygen. Okay. What else? Agua oxinada, baking soda. Those are compounds. So these two elements and compounds falls under pure substance. Next, under mixture, I repeat that this consists already of two or more uh, different substances. Okay, and they are physically combined. Now, there are two sub-classification of mixture depending on how the mixture is produced. Okay, let's say if if it forms uniform phase, one phase, it is evenly mixed, then that's homogeneous. Based on the term, homo means uniform or one. The homo means the same, one, or uniform. Okay, so they are evenly mixed. Good example of mixture that falls under homogeneous mixture are solutions. Okay, so example are solutions. And there are pharmaceutical solutions available in the market. Solutions like syrup, mga, let's say, salt in water, okay, or juices. Those are example of homogeneous mixture. So the particles present in that solution, they are very tiny. Okay, there's actually a range, no, a range of the particle sizes that falls under solution, and they are classified as very small particle in very small particle sizes. Heterogeneous naman is the actual opposite of homogeneous. So hetero meaning different. Diba? Hetero, different, more than one yung phases produced in that mixture. So example of mixture that falls under heterogeneous are colloids. So kindly take note of that. Colloids falls under heterogeneous mixture. Examples of colloids are gelatin, let's say creams. Yan, yung mga creams, milk. Milk is also a very good example of a colloid mixture. And since we have mentioned about colloids, it's also important that you recall the properties of colloids. If you compare the particle sizes of colloids to that of solutions. This time, colloids have a larger particle size compared to solutions. Okay, that's why it falls now under heterogeneous mixture. And there are two important properties of colloids, and those are the Brownian movement or the Brownian motion. That's Brownian movement or Brownian motion. The other one is the Tyndall effect. Tyndall effect is the light scattering effect. Okay, and that is one of the property exhibited by colloids. Brownian movement, that is the zigzag movement of the particles ng colloids at a molecular level. So that's the keyword, the zigzag motion of the particles in colloids. That's Brownian motion. Tyndall effect, that's also known as light scattering effect. What else? Aside from colloids, another example of preparations that are also considered heterogeneous, pharmaceutically speaking, are suspensions. Ayan. Ang mga suspensions are obviously hetero. Di ba? Heterogeneous. Kasi if you try to place a mixture, or let's say a suspension, or store it for a couple of hours, you'll observe that the particles of the suspensions will settle down. Diba? So you can observe it with your naked eye that there are really coarse particles, larger particles present in a suspension. That's why it is termed as suspensions. The particles are suspended in the mixture. Okay, so if you try to compare the three, solutions, colloids, and suspensions, we could tell that colloids, its particle size is intermediate with the solutions and suspensions. Kumbaga, if you compare the three particle sizes, nasa middle, no, yung particle size, intermediate yung particle size ng mga colloids. Intermediate siya between solutions and suspensions. Yung mga suspensions naman, they have larger particle sizes compared among the rest. Okay? So coarse dispersions yung definition also ng mga suspensions. And very common example ng mga pharmaceutically available mixture classified as suspensions. Suspensions are those antimicrobial, mga antibiotic, yung mga kailangang i-prepare, i-reconstitute. I know you're familiar with that term. It has to be reconstituted to be prepared ng mga powder for suspensions. Okay, initially powder siya, present in an amber bottle. Once the customer orders one sa store or sa, let's say, sa drugstore, that's the time the PA, the pharmacist or the pharmacist assistant will prepare the mixture of that suspension, powdered suspension. Ay hara siya butangan of water to be reconstituted, okay, with water. Okay, what's the reason why it is not prepared daan? Okay, it is because of the stability ng preparation. Ang mga suspensions or powder of suspensions, they are not prepared in or mixed initially with water, okay, kasi it is not stable in the long run with water. Okay, that's why it's only prepared once it is consumed na or ordered upon by the patient. So for stability purposes lang gihapon na siya. Why it is prepared as powder, una, prior to reconstitution. Okay, or prior to adding water to that. Okay. What else? So that's all about matter, classification of matter based on constitution, substance, and mixture. And kindly take note of the subclassification. Okay, next. You can also classify matter based on properties. There are two ways how to classify properties of matter. You're familiar with the, uh, I know you're familiar with this, but the most common na properties of matter is the one that is related to the reactions that matter undergoes, yung physical and the chemical property. Okay, so that's also one of the classification of properties of matter, physical and chemical property. Okay, again, that is based on its relativeness to the reaction that matter undergoes, the physical change and the chemical change. So I know you're familiar how to identify if it is physical, if it is chemical property. Okay, so let's just review. When I say physical property, these are just observable characteristics. Okay, so without changing the composition of that matter or of that substance. Chemical this time, if the characteristic has to be reacted, okay, it will cause change in the composition of that substance, and that's the time it is a chemical property. Okay, another properties of matter is based on dependency to the amount of substance. So this one is based on dependency to the amount of substance. Okay? Ayan. So we have two properties based on dependency to the amount of substance. One is intrinsic property, the other one is extrinsic property. When you say intrinsic, in, that's independent to the amount of substance. So it does not depend at all to whatever amount of the substance. You can easily identify that or recognize that substance without knowing the amount of the substance. Example, odor, color. How do you identify odor or color of a substance? Diba? We don't need the amount or the quantity of substance. So it's independent to the amount of substance. Then the rest, density, melting point, freezing point, boiling point, temperature, solubility, malleability, ductility, and the electrical conductivity and resistivity, these are also independent to the amount of substance. Okay, so let me extract one. For example, boiling point, diba? Whatever the amount of water, whether it is a cup of water or a tub of water, the boiling point of water is always 100 degrees Celsius. So it does not depend on the amount of substance. Whatever the quantity of that water is, 100 degrees Celsius yung boiling point ng water. Okay, so same thing with temperature. When you say the standard room temperature, okay, whatever the size of the room is, the standard room temperature will range to 20 to 25 degrees Celsius, diba? That's the standard. So it does not depend on the amount of substance. Extrinsic this time is the one that is dependent to the amount of substance. Example are the following. So it's quite obvious. Mass, volume, length, size, even heat. Heat is a form of energy, a thermal energy. So obviously it will depend. It would depend to the amount of substance. Say for example, yeah, going back to water, you are to compare one tub of water, boiling water versus just a cup. of boiling water. Okay, if we compare the heat, no, the heat energy present in a tub versus a cup of boiling water, obviously the one with higher energy is yung water with higher amount. Diba? Kung sabligan ka, kung isa ka balde nga water, asa mas init, no, mas makapaso, meaning mas naay greater heat energy. Syempre yung one tub of water. So heat is an example of a property of matter that is dependent to the amount of substance. So it's extrinsic property. Okay, so that's all about properties of matter. Intrinsic, independent, then the extrinsic, dependent to the amount of substance. Next. Okay, for the states of matter, you're familiar with this. Majority of the drugs available in the market, they occur in this either of these three states: solid, liquid, gas. These are the common three states of matter. So kindly take note of the differences in terms of particles. So at a microscopic level, how do you describe the arrangement of the particles among solid, liquid, and gas? And the first three, that is the difference ng tatlo based on macroscopic scale. Okay, so diba, when you observe a solid, compare that to a gas, solid will have a fixed shape and volume. Gas do not have fixed shape, do not have fixed volume. The one that can be compressed cannot be compressed is only, can be compressed, sorry. Okay, can be compressed, it's gas. Okay, then the rest cannot be compressed. Okay, that's why yung mga available na pharmaceutical spray, yung gases, di ba, they are compressed in an entity, in a small entity, because gas are naturally compressible. Okay, then the one that do not have flow property, that's solid. Do not have flow property, solid. Okay, just make use of this tabulated na kumbaga data that differentiates the three. Okay, so that's all about states of matter. Okay. Now there are many substances that occur in each of these states, in solid, liquid, and gas. Example, water. Diba? Let's recall the property of water. Water may occur in a form of a solid. Diba? Pwede siyang at solid state, and then if it melts, water will liquefy. Okay, so let me show an arrow to the right. Then if we apply more heat, let's say if we boil liquid water, then it will form vapor state of water. So solid, liquid, gas. So water is a good example that occurs in each of these three states. Okay. On the other hand, it can also undergo phase change, going back from gas, going back to liquid, to its solid state. So if from solid from gaseous water going back to its liquid state, then that we call condensation. Then liquid going back to solid, that's freezing. Okay, so those are important phase changes that you also have to recall. Not only water undergo this phase changes. Aside from water, benzene also undergo this type of phase transition from solid liquid gas, gas liquid to solid. Okay. Other includes nitrogen and iron. Ayan. So these are few examples of substances that undergo the same transition state with water. Okay, let's recall the terms of the phase transitions. If it's from solid directly to liquid, that is liquefaction or melting. So kindly write it, melting or liquefaction, or also known as fusion. That is the phase transition from solid to liquid. Okay, sige, your turn. What about from liquid to gas? How do you term that phase transition? Okay, that's evaporation. Very good. What about from liquid to solid? Liquid going back to solid state. Okay, that is, yes, that's freezing. What about yes, solid to liquid, liquid to gas, solid, liquid to solid. What about gas to liquid? The opposite of evaporation. Okay, that's condensation. Okay, so this time, what if the transition tells us that a solid substance directly changed to gaseous state without passing the liquid state? Okay, that is sublimation. And then lastly, if it is from gas to solid state, then that is deposition. Okay, so for this first four, ayan, about 1, 2, 3, 4. Okay, first four on the list: water, benzene, nitrogen, and even iron na substance. They undergo this four phase transitions. Example of a chemical compound that undergoes sublimation are the organic molecule na or substance na naphthalene, yung mothball. Naphthalene, yung mothball. Also, the inorganic na compound, solid ice, dry ice. Yan. Or the solid carbon dioxide. Okay. And also ammonium chloride. It undergoes sublimation. Also iodine crystals, iodine crystals. Okay, then for deposition, there is no pharmaceutically available na substance undergo this phase transition, yung deposition. Okay, sige, kindly take note of these terms, phase changes. Just recall. Okay, so we're done with concepts about matter. Now let's go on at a molecular level. So we have learned that matter is composed of, yes, substances. Matter can be classified as pure substances, as mixture. Now, at a molecular level, any matter, any substances, they compose of tiny particles. That tiny particles, we call it as atoms. Okay, so you have, I believe you have knowledge, basic information about atomic structure, what composes atoms, who are the influential, most influential persons, no, or scientists contributed to the advancement of our knowledge on atomic theory. So let's learn or let's review about that. So we have different scientists, no, maraming scientists who have significant contribution to the advancement of atomic theory. The first person in the timeline is Democritus. He was the one who coined the term atomus. Okay, so that was Democritus. Based on his explanation about his theory on atoms, he described an atom as a ayan, tiny, then indestructible particle. Okay, so tiny, indivisible, indestructible. That's how Democritus described atom. And John Dalton adopted that idea from Democritus. Yes. So he adopted that idea that an atom is also indestructible, indivisible. In fact, his proposed model on atom is called the billiard ball model. Billiard ball model. So he resembles atom to a billiard ball. Diba? Uh, you have observed that a billiard ball, it's a very hard na spherical material, hard, indestructible, indivisible. So he just actually adopted the idea to what Democritus described atom. Okay, so that's billiard ball model. Also, John Dalton is more known with his postulates. So these are the postulates of Dalton. So among these postulates ng Dalton, as he proposed it, it has experienced invalidations from many scientists. Particularly, I will not read everything, particularly the first two. This is now proven false. Yeah, I know you're familiar with these statements that is not that is not already true. It has been proven wrong already. Elements are composed of indivisible, indestructible atoms. That is already a false statement. It is no longer considered indivisible. Remember that atoms at a molecular level, they can be divided into subatomic particles. Tama? So we have protons, di ba? If this is an atom in an atomic structure, okay, we are observing subatomic particles. On the centermost part are the protons and together with nucleus. Protons and nucleus. And then what surrounds a nucleus are the negatively charged electrons. So this is already considered false statement. It's not indivisible. It can be divided already. And then it says here it's indestructible. Atoms may undergo nuclear reactions. Okay, kindly take note of that. It is not indestructible. It can be destructed. Atoms may undergo nuclear reactions. Okay? So yung first postulate is already a false statement. Also the second postulate. Atoms are identical for a given element. So this is false. Remember, we have the concept isotope. Okay. Ayan. So kindly take note. Because of the concept isotopes, then the second postulate is already a false statement. Okay, let's recall what is in isotope. How do we describe an isotope? These are same element. Same element. So if the same element are being described, then they would have the same atomic number or same proton number. Atomic number is just equivalent to proton number, right? So same atomic number or same proton number, but they differ, but different neutron number. Okay? So we cannot say that atoms of a given element are identical at all aspects. Let's say, for example, when you talk about hydrogen, atoms of hydrogen na element, they are all identical at all aspects. They have the same neutron number, the same proton number, electron number. No, not all the time, because we have isotopes of hydrogen. Diba? We have 3 isotopes of hydrogen, and this 3 isotopes of hydrogen have different masses because they have different neutron number. Okay? By the way, when you write uh, or represent an atom showing its mass number rather, showing its mass number are written on top, left side, topmost. That's mass number. This one is proton number or atomic number. So when you represent an atom, make use of this representation. Yung X will serve as the symbol of the element. Then capital Z written on the left side bottom part. No? Left side bottom part. That's proton number. Ayan. It's already written here. Proton number or the atomic number. Then capital A. That's mass number. That's how you represent an element showing its atomic number and mass number. So these are the 3 common isotopes of hydrogen, and it has names, diba? Yung most common, most stable, the most common, stable, abundant, most abundant isotope of hydrogen, that's protium, followed by deuterium. Then this one is protium. So because of this concept isotope, not all atoms are alike. Not all atoms of the given element are alike. Okay, and the rest of the elements like carbon, oxygen, and many more, many more selected na mga atoms of an element, they have existing isotopes. Okay, let me give you another example. Let's say oxygen. Okay, so there are 3 isotopes of oxygen. Okay, and 6. So we have, sorry. They should have the same proton number. Ayan, so 8. That's the proton number of oxygen, but they have different masses because of the differences in neutron number. Okay, so we have oxygen with a mass of 16, with a mass of 17, with a mass of 18. Okay, so they have different masses. The reason ng different masses because of differences in neutron number. How do you compute the neutron number? You just subtract the given value ng mass number to the given value ng atomic number. So A minus Z. Mass number minus, tritium. I think tritium akong giingon, pero akong gisulat kay protium. Yeah. Sorry for that. Sige. Thank you for correcting me, Miss Sulaiman. But I remember I mentioned tritium. I just wrote it protium. Sige. And the rest of the postulates are still applicable in the concepts of chemistry. In fact, because of these postulates, remaining postulates of John Dalton, there are three fundamental laws of chemistry that have been formulated. Okay, so we have the most common, the law of conservation of mass, or the law of mass conservation. This was formulated or discovered by Antoine Lavoisier. Okay, by Antoine Lavoisier. Yung law of multiple proportion, this was investigated by John Dalton. And then the law of constant composition, investigated by John Prost's, or this is also known as Prost's law. Okay, Prost's law by John Prost. Okay, so you kindly take note of the person, scientist behind the discovery or formulation of these fundamental laws. Okay, let's recall the information or concept about each law. So law of conservation of mass, this tells us, let me change the color again. It tells us that the mass of the material reacted before and after, it remains the same. So kindly take note of that. The mass of material being reacted before and after, they remains the same. Because remember, matter is, it is never destroyed nor created. So that's the reason why mass is always conserved in the reaction. Okay, so matter is neither created nor destroyed. Okay, so that's all about law of conservation of mass. That's why it is always practiced that when you write chemical equations, predicting the products, completing the chemical equation from the reactant side to the product side, you always balance the chemical equation because that reflects law of mass conservation. Law of multiple proportion, let me write it first. This states that if two elements form more than one compound, let me write it first. If two elements form more than one compound, okay, the masses of the second element is expressed in small whole numbers in combination with a fixed mass of the first element. Okay, so that's the statement if it tells us that the law of multiple proportion is demonstrated in the reaction. Okay, so a good example here, it's better to give an example to easily apply the fundamental law or to better understand the law. So example, you have two elements. It says here two elements. Two elements, let's say carbon and oxygen. So these are two elements, different atoms of elements. When they combine, possible they can form more than one compound. There are reactions wherein if you combine carbon and oxygen, you will form carbon monoxide. There are also reactions wherein when you combine the two elements, carbon and oxygen, you will form a more stable oxide of carbon, and that is carbon dioxide. Now try to observe that the two compounds, look at the two compounds formed. They consist of the same element, carbon and oxygen. The only thing that they differ is on the second element, wherein yung second element, their masses are expressed in whole numbers. Diba? They differ on masses. For carbon monoxide, there's only one atom of oxygen. For carbon dioxide, there are two atoms of oxygen. So the masses of the second element is expressed in whole numbers. And always the first element in fixed mass. Okay, another example, let's say nitrogen and oxygen. If you combine the two elements, you can form more than one compound. You may form nitrogen monoxide, nitrogen dioxide. Okay, now observe the two compounds. They only differ on the second element. Diba? Yung second element have different masses expressed in whole numbers. So that's all about law of multiple proportion. Next, law of constant composition, or this is also known as Prost's law, or this is also the law of definite proportion. Please take note of the synonyms. Definite proportion. Okay. So how do you apply law of definite composition? So let me write here. We'll say law of definite proportion, constant composition. It says that a chemical compound, regardless of its source, regardless of its source or method of preparation, it remains the same. It have the same composition. Okay? Sige. Ayan. So, chemical compound have the same composition regardless of its source, regardless of its method of preparation. Ayan. So, example, if you are to compare purified water versus rainwater. Ayan. Purified water or rain water. Okay, whatever the source is of that chemical compound, the compound water, its composition is always consisting of two atoms of hydrogen, one atom is of oxygen. Okay? Or let's say salt. Let's say your table salt at home and our table salt here, diba? Whatever the source where you buy that salt, ang salt is always NaCl. So that's all about definite composition or definite proportions. Okay, so these are the three fundamental laws of chemistry: conservation of mass, multiple proportion, and constant composition. Okay, so again, this time, let's review the those influential, the most influential persons who contributed a lot in the discovery of atomic structure, who discovered electrons, protons, neutrons, and other scientists who have proposed models of atoms. Okay, sige. So let's try to fill in the blanks. Who is that scientist who proposed the model raisin bread model or plum pudding model? Okay, raisin bread. This is also known Plum-Podic model is also known as raisin bread model. Okay, so that was J.J. Thomson, correct? J.J. Thomson. Okay, so in in his time, he was able to explain properties of the cathode ray tube. And because of that, he was able to find out that there are negatively charged particles of an atom. So he was the one who discovered as well electrons. Okay, he discovered electrons. So kindly take note of that. So that's the main contribution of J.J. Thomson. And kindly take note of the rest. So if we try to illustrate the model, raisin bread model, plum pudding model, it looks like this. Atom is positively charged. So there are positive charges wherein embedded are negative charges. So embedded are negative charges. So it looks like a raisin bread. The raisins on top of the bread, no, or the cookie like nga bread, yung mga raisin will serve as the negative charges. So it looks like that. So yun yung resemblance ng atomic structure na he was able to propose. Okay. Then the one who conducted the oil drop experiment, who was that? Okay. So Robert Millikan. So R.A. Millikan. It was Robert Millikan who conducted the oil drop model, and he was able to uh, determine or measure the accurate mass of electron. Okay, that's all about oil drop experiment conducted by Millikan. Next, we have Wilhelm Röntgen. Kindly take note, Wilhelm Röntgen. So his study focused on very penetrating rays from cathode ray tube, not deflected by magnet. And it was Henry Becquerel who discovered chemicals decomposing spontaneously, giving off very penetrating rays. Example of very penetrating rays are the X-rays. No, X-rays, they uh, kumbaga give off penetrating rays. Okay? So kindly take note of their important contributions. Sige, let's proceed. Ito, kabisaduhin lang no yung pangalan and their main contributions. Oh, where is it? Ayan. Then the one who discovered or studied uranium, uranium and thorium, okay, Marie Curie. That was Marie Curie. And together, listen, this three na bullets, under na siya kay Marie Curie. So she studied uranium, thorium, discovered polonium, radium. Particularly with radium, dalawa sila nag-discovered ng radium. Kasama niya yung husband niya, si Pierre Curie. Ayan, Pierre Curie, double R. Ayan. So they discovered the atom, the radioactive atom nga, radium. So her study focused more on radioactivity. That's why yung mga na-discover niya no, ng mga elements or radioactive elements like uranium, thorium, polonium, and radium. Okay, nuclear atomic model. This was proposed by, okay, your turn. Letter E. Okay. Ernest Rutherford. Yes. Ernest Rutherford alpha scattering experiment, the nuclear atomic model. So this is actually the opposite of the one proposed by Thomson. So opposite yung atomic structure nila na pinopose. Yung kay Ernest Rutherford naman, based sa nuclear atomic model, nag-focus siya sa nucleus. Kaya nga nuclear atomic model, ang atom daw, it has an empty space sa centermost part, wherein yung mass niya is concentrated at that centermost part, and it contains protons. So nandyan daw yung protons in one area, which is correct. Diba? When we describe an atom structure, what is inside the nucleus are protons together with nucleus. Okay, so that's all about Ernest Rutherford's nuclear atomic model, opposite of Thomson's model. Okay, so with this discovery or model by Ernest Rutherford, he discovered yung protons naman. Siya yung nag-discover ng protons, yung positively charged particles of atom. Okay, planetary model proposed by, okay, ito very known man ito, Niels Bohr. Yes. Yeah, Niels Bohr. Correct? So that's planetary model. So meaning to say yung electrons daw surrounding an atom, surrounding a nucleus, they move around the nucleus in a circular orbits. Circular orbit. So if I were to illustrate it, it looks like this. Okay. Ayan. And then we have the positively charged atoms in the centermost part. Then yung electrons are surrounded sa nucleus, around the nucleus. Okay, so that's Niels Bohr. And then last, the one who discovered neutron was, sige, James Chadwick. Okay. I think that's all sa discovery, historical discovery on atomic structure. So kindly take note of the names. During board exams, possible merong dalawa or isa. Isa sa mga pangalan. No? So you have no choice but to study everything. Okay, sige, atomic structure terminologies. Okay, let's move on the terminologies. These are also basic information, and please do not forget that when you say atomic number, this is also equivalent to the number of proton. Yes, number of protons. Okay, what else? Ang atomic number or the number of proton of an atom, it is also equivalent to the number of electron, provided that the given atom is neutral. So if neutral atom, then we could tell proton number is equivalent to the number of electron. If neutral yung atom. Let's say the given is sodium, no charge at all. Diba, sodium has an atomic number of 11. You are asked for the number of electron, then we could say it has also electron number of 11, provided that the given atom of sodium is neutral. However, if the given this time is a charged atom of sodium, the ion form of sodium, which is Na+, that's the time proton number is not equivalent to electron number. For a while, give me 1 second. Sorry for that interruption. I have to assist my grandfather. He actually called me. Sige, let's resume. So where are we? Ayan. So given this time, a charged atom, that affects the number of electron. It's not already total of 11, but the charge will tell us what happens to the number of electrons. If it carries positive charge, then it means that the atom loses electron. Okay? So if it loses one electron, kasi plus one meaning losing one electron, making it cation. So this time, the number of electrons here would be total of 10. Okay, so dito, neutral, that is 11. Okay, please do not forget cations and the anions. If it carries positive charge, that's losing electron. Electrons are naturally negatively charged atoms. So if you are losing negative electrons, mas nagiging positive yung atom. Kasi nawalan ng mga electrons nga negative, kaya it will now become more positive. Okay, so that's losing electron. Please do not confuse it with the mathematical operations that if it is plus, then you are adding. Okay, so this is a different concept because we're talking about electrons, the losing and then the adding of electrons. Okay, so kindly take note of that. What else? Okay, proceed. Mass number. I've mentioned this earlier. Mass number, that is the total if you add neutron number and the proton number. This is actually if you try to, kumbaga, get the operation out of the equation I have provided earlier. Neutron, diba? I told you, neutron is equivalent to atomic mass minus the proton number or mass number. This is mass number minus atomic number. I have mentioned this earlier, how to determine neutron number. So for you to determine mass number this time, you can extract the equation out of that initial equation I have provided. So how will you get mass number? You transpose proton number on this side. So that would be neutron number plus proton number. Proton number is capital Z. Okay, so that's mass number. So you kindly just move the detailed on the underlined part. So that's it. That's all about mass number. When you say average masses of all the isotopes of one element, then that is atomic mass. Okay? So that's atomic mass. It's almost the same. Almost the same lang naman yung value, but the definition technically merong differences sa definition. Kapag average na ng lahat ng isotopes of that one element, then we call it as atomic mass. And then when we say proton together with neutron, diba? If this is the atom, the centermost part of the atom consists of proton and also a neutron. So the combination of that two, we call that as nucleon. Okay? So kumbaga the centermost part of the atom consisting proton and neutron, that's nucleon. Okay? So these are just recalling terms. Isotopes, I've mentioned this earlier. What's an isotope? Atom of the same element. Same yung proton number, diba? Kapag same element. So let me write it. Atoms with Yes, same symbol kasi same element with same proton number but different number of neutron. Okay, so that's isotopes. I have mentioned few examples. When you say isotones, by the way, for you to easily recall na kapag isotope, ang the same is proton number, you highlight letter P. And if it is isotones, highlight letter N para you can easily recall same yung neutron number. So atoms with same number of neutrons. Okay? So that's isotones, same number of neutrons. Kapag isobars naman, when you say bars, mass. Okay, that's the meaning of bars or baros. It actually comes from the word baros. When you search about the word baros, it has something to do with masses or weight. Okay, weight. So atoms with the same atomic masses. Atoms with the same atomic masses. Ayan. Sige, let me give you example. Let's say, for isotones this time, kasi I have provided earlier examples for isotopes. Let's say for isotones, carbon, nitrogen, and oxygen. Okay? So, we actually have um, oxygen, oxygen atom with a proton number of 8. Diba ang proton number ng nitrogen is 7. Then 6 naman yung carbon. Okay? And then for the masses, 16 for oxygen, 15 nitrogen, then 14 carbon. Now try to get the neutron number for each. You will observe they will just have the same number of neutron. And that is total of ilan? That would be 8, di ba? Try to compute that. You do the math at your end. That's total of 8. So lahat sila, carbon, nitrogen, and oxygen. Given that set of atoms, we consider them as isotones because they have the same neutron number. For isobars, a good example would be, let's say, potassium. Ayan. Potassium and also calcium. Okay? You tell me, what is the atomic number of potassium? Di ba potassium is 19. And then calcium is 20. Okay, we're talking about atomic number, ha? Then there are atoms of potassium and calcium na yung masses nila is 40. Okay, 40, 40. So given that set of elements, set of atoms, you will observe they have the same atomic masses, 40, 40. So that's isobars. We consider them as isobars. So that's how you apply the concepts. Isomers, you have encountered this many times in your organic chemistry. Kapag isomers, the same yung formula. Same yung formula, but different yung structure. Okay, so that's isomers. And good examples of organic compounds wherein isomerization occurs, that would be among carbohydrates. Yung mga carbohydrates, they exhibit isomerization. Okay, so let's fill in the definition given: aggregate of two or more atoms in definite arrangement held together by chemical bonds we are simply referring here to molecules. Okay, diba? Ang molecules, it is composed of two or more atoms. And they are being arranged, held together by chemical bonds. What do you call that term? Known as charged atoms. May it be positively charged atoms, or negatively charged atoms. How do you call that? Okay, so that's ions. Very good. So we have two types of ions. I've mentioned earlier, cat ions, highlight letter T. And then we also have anions, highlight letter N. Okay? Then kindly take note, i-recall nyo yung definitions or differences, distinction ng molecular form or molecular formula versus empirical formula. Kindly take note when you say molecular formula, that is the exact number of elements. The given formula will tell us the exact number of atom or the exact number of element in that compound or in that molecule. When I say empirical formula, it's the simplified formula. Okay, or this is defined as the simplest formula because the masses of each atoms are expressed in small or simplified whole numbers, simplest whole number ratio. So example, benzene. Di ba you're familiar with benzene? Its molecular formula is C6H6. Diba? That is benzene. That's the molecular formula of the compound, the molecule benzene. How do we identify its empirical formula? Empirical formula, again, is the simplest whole number ratio, meaning you have to get the common denominator of the subscripts. Diba? 6, pareha sila 6. We can simplify that subscript. They have common denominator and that is 6. So, i-divide mo siya sa 6 divided by 6. So, we could tell that the empirical formula for benzene molecule is CH. I hope you got the point. What is molecular formula, empirical formula? Ang empirical formula, simplified na siya. Gipa-simplify lang ang mga masses. Okay? Okay, another example, yung sa sugar. Okay, yung glucose. Yung glucose, diba, is yung molecular formula niya, meaning kung ilan talaga yung carbon, hydrogen, oxygen sa glucose, diba, 6 yung carbon, 12 yung hydrogen, yung oxygen, 6. So that's glucose. C6H12O6. That's the molecular formula of glucose. Now, you tell me, what's the empirical formula of glucose? How will you simplify that? Pinaka-simplified. Get the common denominators ng mga subscripts. Sige, go ahead. That would be, okay, very good. That would be CH2O. Correct. That's the simplest whole number ratio. That's how you get the empirical formula. So please take note of the difference between molecular formula at saka empirical formula. Ito, I have reviewed this already, diba? Isotopes, isobars, isotones. Just highlight the key letters para you will easily recall, okay, this is isotopes, isotones, isobars, isomers, okay? Sige, proceed. Are you following? Kaya pa? Give me a thumbs up if you are still okay at your end. Thumbs up. Sige. Let's proceed. Naming. Okay, naming of inorganic compounds. So, under inorganic compounds, we have the following: covalent, ionic, and even acids are considered inorganic compounds. Covalent compounds, ionic compounds, acids. No problem with acids because you can easily identify, based on the chemical formula, you can easily tell if it is an acid as long as it has proton in it. Kasi remember, acids are said to be proton donor. So dapat, when you check the chemical formula, okay, it should have proton. It should have hydrogen ion. Ang covalent and ionic compound, please take note, the components. When you say covalent compound, it is composed of nonmetals bonded together. Nonmetals to nonmetals, meaning there is only sharing of electrons. Sharing of electrons occurs, no, kapag covalent compound is formed. So if there is sharing of electrons, then covalent bond, covalent compound is formed. And that occurs between nonmetals. Kapag naman ang bonding is between metal to non-metal, then we form ions, ionic compound. Okay, that's why on the next slide, you are seeing cation, combining it with anions, then we form ionic compound. And what happens here, why ionic bond is formed or ionic compound is formed, there is transfer of electrons. Can you take note of the terms, ha? Kapag transferring ang involved, ionic compound. Kapag nag-share lang ng electrons, covalent compound. When you say transfer of electrons, meaning yung isang atom nagbigay, another atom naman nag-accept. Okay, so yung isa nag-donate, yung isa naman nag-accept or nag-gain ng electron. That's it. Okay, going back to covalent, sharing of electrons. Regarding the electrons being shared in a covalent bond or in a covalent compound, it may differ, right, depending on how electrons are being shared. If the electrons are unequally shared, unequal sharing of electrons, a specific type of covalent bond is formed. And we call that as polar covalent bond. Okay, so that's polar covalent bond if unequally shared yung electrons between non-metals. Kasi 'di ba kapag covalent, non-metals to non-metals. And then kapag equally naman, equally shared yung electrons among non-metals, then we term that as non-polar. I know you're familiar with this. Non-polar covalent bond. Okay. Okay, so there might be question that you will encounter later on. You are asked if it is a polar or a non-polar covalent bond. Just recall that it is said to be polar covalent bond if one of the atom, one of the non-metal atom being bonded is a highly electronegative atom. Kapag may presence, ha, take note. That's your main hint. Presence of highly electronegative atom. What are examples of highly electronegative atom? Fluorine followed by oxygen, nitrogen, and yung mga halogens. Halogens like chlorine, bromine, iodine. Okay, chlorine, bromine, iodine. These are highly electronegative atoms. So let's say, for example, you are asked, no, in the question, which between the two is a polar covalent bond? Letter A or letter B? What will be your answer? Okay, that would be polar covalent bond. What would be your answer given the concept? Okay, letter B. Kasi sabi natin, di ba, your hint for you to easily recognize it is a polar covalent bond, there should be presence of highly electronegative atom. And that highly electronegative atom is bonded to a least electronegative atom. So oxygen is one of the highly electronegative atom. These are non-metals, diba? Non-metals. Obviously, covalent bond is formed. Okay? So this is a polar covalent bond. Yung non-polar covalent bond, generally, they occur between identical atoms being bonded. Example, iodine bonded to iodine, hydrogen bonded to hydrogen, or it may also occur between non-identical atoms. Carbon and hydrogen, these are not highly electronegative atom, right? Ang carbon and hydrogen, least electronegative man ito. So these are not polar covalent bond. Yung bond na to that connects carbon and hydrogen is obviously non-polar as well. Kaya nga 'di ba ang mga hydrocarbons, ang mga organic compounds rich in hydrocarbons are generally non-polar in nature. Okay, so non-polar yan na covalent bonding. Okay, so kindly take note of this. And if you can identify also the range, the electronegativity range or electronegativity difference between polar covalent bond at saka non-polar covalent bond, that is also important na you recall. Okay, sige, let me write here. Kapag polar covalent bond, ang electronegativity difference, that is from 0.5 to 1.7. Kapag naman non-polar, from 0 to 0.4. That's the electronegativity difference. Okay? Why is it until 1.7 lang kapag puro covalent bond? Kapag covalent bond, ang electronegativity difference is until 1.7 only because kapag ang electronegativity difference is already 1.7 above, then that is already ionic bond. Okay, that's already ionic bond, which is highly polar bond. Okay, obviously, polar good ang bond, no, formed sa ionic bond. Kasi ang isa, negatively charged, yung isa, positive charge. Magkaiba kasi yung pole. So talagang ang pool of electrons, attraction ng electrons is going to anions, the highly electronegative na atom. Okay? So kindly take note of that. Sige, let's have the naming. How do you name binary covalent compound? These are easily named kasi you just have to name the first atom based on its non-metal name. Diba? Yung unang elemental symbol of a non-metal, it is just named based on its non-metal name. So carbon, this is a carbon, carbon, silicon, ayan. So yan yung mga unang element. Unang element in a binary covalent compound. The second element, it is named with an oxide ending. I mean with an IDE. With an IDE ending. Lahat ng second element, it should ends with IDE. So from oxygen, this becomes oxide. Okay? Oxide. Okay, another important information that you have to take note is the use of Greek prefixes. Use of Greek prefixes, this is very important to identify how many atoms present in that compound. Example, for oxygen, it has only one. So you have to make use of a Greek prefix that tells us there's only one oxide. And the Greek prefix for one, diba, is mono. Okay, so monoxide. Okay, so carbon monoxide. Next, carbon, diba, that's chloride. How many chloride? There are 4. So the Greek prefix for 4 is tetra. So you have tetra chloride. Okay, silicon, followed by oxide. How many oxide present in the given compound? Dalawa. The Greek prefix of 2 is di. So dioxide. Next, There are two, nitrogen. So you have to use Greek prefixes, nitrogen, followed by 5-oxide pentoxide. Okay? And then you have here dinitrogen monoxide. Okay? It never will happen that uh, you use two vowels na consecutively written yung two vowels. Yung vowel from the ending of the prefix mono and the vowel from the first letter of oxide. Dili pwede nga mag-abay ang duha ka vowel. So you have to drop the letter O from mono that makes it monoxide. Another example, sa pentaoxide, instead of saying pentaoxide, you have to drop the vowel, letter A from penta, para dili consecutively written ang mga vowel. Okay? Ano yan? Grammar nga ruling. Okay? Bawal na mag consecutively written ang mga vowels from a prefix, then from the root name of a word. Okay, so you have to drop the vowel from the prefixes. So pentoxide na, hindi pentaoxide. Okay, what else? Yung mono. Yung mono is not used in the first element. That's why try to observe the first three example. It's not monocarbon, monosilicon. Mono is only used on the second element. So those are the important notes that you have to remember in naming covalent compounds. Binary. Binary meaning two elements only. Binary, two elements. Okay, next. Let's proceed to ionic. Ionic compounds. Okay, in naming ionic compounds, of course, your foundation here is to review this one. The list of ions. Okay, I know you're familiar with this. If you memorize the cations and then the anions, you can easily write chemical formulas and name ionic compounds. Okay? Kasi again, what composes ionic compound are cations first, followed by anions. Okay, so you have to review here, review list of cations and anions. Just recall the most common. Okay, now I'll give you a way how to easily memorize these charges. You need to recall the valency. What do you mean by valency? It tells us how how many electrons it gains or it loses during chemical reaction. Okay, so you have to be familiar with the valency of the elements. Recall that the elements, diba, are grouped in vertical row up to bottom, from top to bottom. Yan yung grouping or groups or the vertical grouping. Okay, so let me write it first. For you to easily, kumbaga, familiarize the charges, just recall that majority of the elements that falls under group 1A, they carry +1 charge, meaning during chemical reaction, they loses 1 electron. Ito. Diba, this is the periodic table. This is group 1A. Ayan. So yung mga 1A elements, during chemical reaction, they loses 1 electron. That's why they carry +1 charge. Ang mga 2A naman, group 2A elements, they carry plus 2 charge. Ang mga 3A elements carry 3 plus charge. Of course, ang mga 4A elements, yung sum plus 4 charge, yung iba naman negative 4 charges. Yung mga group 5 elements, they carry plus 5 charge or negative 3 charge. I'll give you example later on. 6A elements, negative 2. And then sa 7A elements, negative 1. Sige. Kindly take note of this and then we'll go to the periodic table. Sige, example. No problem with 1A, 2A. 1A, then 2A elements. Kasi you're familiar that, diba, sodium, for example, this is very common. Sodium's ion form is always Na+, example, potassium also, plus. Magnesium, diba, under siya sa 2A, so generally, when they form ions, that's 2+. Calcium, another example, 2+. Aluminum, diba, if it forms cation, it's Al, 3+. Okay? Nitrogen, phosphorus, it falls under 1, 2, 3, 4, 5. No? Nasa sa group 5. Going back to our slide, try to check. Ang mga group 5A elements, when they form ions, they may carry negative 3 or positive 5. For nitrogen, forming nitride, it will carry negative 3. Phosphorus, if it forms ion, it's negative 3. Phosphide yung tawag. Nitride, phosphide. Arsenic, marami siyang charges, di ba? Pati ang antimony. It's either plus 3 or plus 5. Ganon din sa antimony. Plus 3 or plus 5. So, variable charges. Oxygen, sulfur, selenium. Ganon din if they form ions, negative 2 naman. Ayan. Group 6, group 6. So, example, oxygen. It forms oxide. Oxide is negative 2. Sulfur becomes sulfide, negative 2. Selenium becomes selenide, negative 2. Ayan. Then the rest of the halogens, diba group 7, mga halogens. Negative 1 naman, diba? Ang chloride, fluoride, bromide, iodide, when they form ions, anions, negative 1 yung charge nila. So that's valency. It tells us how many electrons are being donated or being gained, accepted during chemical reaction. Okay, valency. Sige, so you have to review cations and anions for you to easily name ionic compounds. Now, distinct about ionic compounds are those containing cations formed from transition metals. Okay? Kasi yung mga transition metals, those atoms located in the middle portion of the periodic table, like copper, mercury, iron, nickel, cobalt, yan. They are capable of forming variable charges or differing charges. Example, copper, yung copper na charges as an ion, as a cation, pwedeng +1, +2. Okay? Same with the rest of the listed transition metals. They form varying charges. So let me write it. So mercury has a +1 charge or could have a +2 charge. Iron could have +2, +3. Same with nickel and cobalt, +2, +3. And then tin and lead, meron silang either +2 or +4 charge. Ayan. So kindly take note of this. Then bismuth as arsenic and antimony. they could carry charges +3, +5, and yung manganese have a lot of oxidation state. Marami siyang oxidation state. But the most common is +2 and +3. But also add here +4 and +7. Yung manganese na ion form is more commonly occurred in manganate form. Diba? Example, potassium permanganate. And then lastly, yung chromium. Yung chromium, it has +2, +3 na charges. Yung occurrence naman ng chromium is in a form of oxy anions. Yung chromate at saka yung dichromate. Yan yung commonly occurrence ng chromium as an ion. Okay? So as chromate, that's CrO4, 2 negative. And as dichromate, that's Cr2, O7, 2 negative. Okay? Kindly add here also, it's not written, yung gold. Gold is also capable of forming variable charges. It has a +1 and +3 charges. Okay, so these are the possible charges that these transition metals may exhibit. Okay, yung occurrence nila as ions, as cations. Now, in naming ionic compounds containing these metals capable of varying charges, we can make use of the stock naming or the stock method or the classical method. When you say stock method, that is also known as the systematic name, meaning the new name. The classical one is the traditional or the old way. That's the old method in naming. Okay, let's have first the stock or the systematic names ng ionic compounds containing transition metals. Okay, stock method, this includes Roman numerals. Okay, so it includes Roman numerals. Yung Roman numerals, that indicates the positive charges of the transition metal. Indicating positive charges of transition metals. So example, if you are asked for the stock method name, equivalent stock method name of the given ionic formula, then this could be named as lead 4, enclosed in a parenthesis, yung Roman numeral na 4, that is to indicate the positive charge of lead. Positive charge of lead is 4, basing on the chemical formula. Then the anion nitrate. Okay, so that's lead 4 nitrate. That's the stock method name or the classical name of lead nitrate. It's lead 4 nitrate. I know, yeah, the systematic name rather, systematic name. The classical or the traditional old method naming, that is the use of Latin prefixes, using Latin prefixes. Latin prefixes plus the ik or us suffixes. So that's it. That's the old method, although it is phased out already or not commonly used nowadays. But please take note also that there are names ng ionic compounds that makes use of the classical method. So paano yung classical method? You make use of the Latin root name of the transition metal. Example for copper. The Latin name of copper is cuprum. Cuprum. Okay, so from cuprum, you can make use of the ending ik, us added to the Latin name cuprum. This signifies the ionic charges. When you say cupric, that resembles the one with a higher charge. Cuprous, that resembles, indicates the one with a lower charge. So kapag yung lower charge, Cu+, that's cuprous. That's equivalent to cuprous. Yung higher charge representing higher charge ng copper, that is also named as cupric. So this naming is based on classical method or the old way of naming the transition metals when they form differing charges or variable charges. Okay, so from cuprum, this is obviously cupric. No, this is cupric. Kasi this is copper 2 plus, then sulfate 2 negative. Okay, so you are not seeing subscript of 2 in the given compound cupric sulfate because it has been simplified into 1. Subscript of 1 is not anymore written. Okay, so yung classical name equivalent ng given compound dito would be cupric sulfate. And then the stock or the systematic name dito, you make use of the Roman numeral following the non-metal name. Non-metal name is copper, followed again by the Roman numeral 2. Roman numeral 2 because that indicates the positive charge of copper sulfate. And then dito naman, the classical name, this is plumbic. For lead 4 nitrate, this is plumbic nitrate. Okay, so kindly take note of that. So you try to apply the traditional name equivalent of these transition metals. Just remember that the ik ending represents higher charge. The us ending represents lower charge. So this encircled charge of mercury, kapag mercury, that is actually Hg2, 2 plus. So equivalent to +1 lang gihapon. Kasi if you try to simplify it, di ba? Kapag na-simplify mo siya, it's also +1 and that's mercurous. Mercurous. Ito naman yung mercuric. Okay? Ferrous, ferric. Cobaltus, cobaltic. Okay? Stannous, stannic. Plumbous, plumbic. Yan. That's how you apply the classical method of naming. So this only applies to transition metals capable of variable charges. Sige. So done with naming. So going back, we were able to review naming covalent compounds and then ionic compounds. Sige. Okay, here. Regarding oxyanions, these are also very important that you recall the common oxyanions of the nonmetals for you to easily extract the equivalent ith form of these oxyanions. By the way, when you say oxyanions, these are polyatomic anions containing oxygen. And per nonmetals, these are all nonmetals, no? Nonmetals. They exhibit common oxyanions. Common oxyanions ends with suffix 8. Example for nitrogen. The common oxyanion of nitrogen is nitrate. Common oxyanion of sulfur, it's sulfate. Okay. For phosphorus, it's phosphate. For tin, it's stannate. And for chlorine, it's chlorate. Okay? If you wanted to extract its ith form of these common oxyanion, that is only one less oxygen. One less oxygen of these given oxyanion on the left. Example, if you wanted to extract the nitrite form from nitrate, diba, these are 8, ending in 8. From nitrate, you wanted to extract the ith form, nitrite. One less oxygen, so that would be NO2. Negative, no changes in the charge. From sulfate to sulfite, that would be SO3. So one less oxygen. For phosphate, PO3. Stannate, magiging stannite, that would be SNO3. Then from chlorite to chlorite to chlorite, that is ClO2 negative. Okay? Sige. You can extract the acids out of this, equivalent acids out of this oxyanions. So that's the reason why uh, I need to I need you to recall all about oxyanions for you to derive acids. So how will you derive acids out of anions? Okay, it depends on the ending of the names of anions. There are anions ending in IDE. Example, the anion fluoride, bromide, diba? Iodide, cyanide, diba? These are anions ending in IDE. You can derive acids out of that anions. There are also anions ending in 8, ending in height. So these are examples I have written on the previous slide. Diba? These are also anions, but this time ending in 8, ending in height. Still, you can derive acids out of those anions. So how do we name acids out of anions? Okay, let's recall that if the anions end with IDE, you simply change the IDE ending to ic acid, then add the prefix hydro. That's it. So meaning from, diba, this is chloride. That's the name of the anion, Cl negative. How will you extract the acid equivalent out of that chloride? Change the IDE ending to ic acid. So that makes it chloric acid with a prefix hydro. Okay? So that makes it hydrochloric acid. How do you write hydrochloric acid? Remember, all acids starts with hydrogen ion. They consist of hydrogen ion. So make use of the crisscross method to write chemical formula. You cross over the numerical value of the charges. So that would be HCl. Okay? Fluoride. Kung fluoride, yung given, how will you extract the acid name? Change the IDE ending to ic acid, then add the prefix hydro. So that's hydrofluoric acid. So that would be HF. No? Hydrofluoric acid, HF. So on and so forth. What about anions ending in 8? Example, nitrate, sulfate, phosphate, stannate, chlorate. How do we derive the acid name? You simply change the ending 8 to ic acid. That's it. Okay? So that's the difference between ide at saka 8. Kapag 8, ending in 8 yung anion, gawin lang ic acid yung 8. No more prefix, hydro. Okay, so example, diba, this is nitrate. What is the equivalent acid name? You can derive from the oxygen ion nitrate. So that would be nitric acid. Diba? Gawin lang ic acid yung 8. Okay? For sulfate, of course, the most appropriate term, it's not sulfic, ha? The appropriate term for that acid is sulfuric acid. There's no such chemical named as sulfic acid. It's sulfuric acid. Phosphate, that would be phosphoric acid. Stannate, that would be, stannic acid. And then finally, chlorate, that is chloric acid. Okay, so that's it. Then let's proceed to ite. What if this time the anion ends with suffix ite? So how do we derive the acid name? Now let's recall, just change the ite ending to us, acid. Sige, your turn. How do you name the acid derived from nitrite? That would be, sige, your turn. What's the name of the acid? Change the ite ending to, okay, very good. That would be nitrous acid. So you do the rest during your independent study. Okay, this is, diba, sulfite, phosphite, stannite, chloride. Change the ite to us acid. That's it. Okay? Sige, next. Sige. Since we are done with naming inorganic compounds, the ionic compounds, the binary covalent compounds, and acids, let us also recall all about mole relationship. I will just insert it because I believe this is also important. It requires somehow computation. If you have scientific calculator, make use of that. I'll just give one example. Let's recall the mole relationship. Any substances that you encountered, any substance, 1 mole of it, 1 mole of that substance or atom, entity, ion, that has a constant equivalent of Avogadro's number. Okay, and that is 6.022 to the power of 23. This is the equivalent, Avogadro's. This is constant. Avogadro's number. Okay? And yeah, you might encounter no question, what is the Avogadro's constant or Avogadro's number in identifying mole relationship? That's 6.022 times 10 to the power of 23. Okay? So any atoms, any molecules, any substance, any ions, any entity, any chemical entity, 1 mole of it is also equivalent to 6.022 times 10 to the power of 23 atoms per molecules. When you say mole, that's a unit of measurement. That is also equivalent to molecular weight in grams. Molecular weight in grams. Okay, so meaning to say, if you compute for the moles, moles, it's not clear, no? I'll change the color. Ayan. Or it has a symbol, letter N, small letter N. That is also equivalent to mass in grams over molecular weight. Okay? That's the kumbaga formula how to get a mole of a substance. So molecular weight in grams grams mass over molecular weight. So I'll give a sample nga computation how to apply mole relationships. Okay? Kasi this concept, you can make use of this mole relationship if you wanted to convert a mole of a substance to its mass, okay, mass equivalent or mole equivalent. Okay? Given the Avogadro's constant, again, given the Avogadro's constant, you can convert the amount, no, to its mass or its equivalent mole. Let's say, for example, you are asked, how many atoms? How many atoms are there given the mass of sodium hydroxide, which is 20 grams. Sodium hydroxide at 20 grams. This is only the given nga, kumbaga data. Then you are asked how many atoms of that molecule, sodium hydroxide, are there in 20 grams. How many atoms of the molecule sodium hydroxide are there in 20 grams. So you make use of this information na to get the number of moles, always take note, ang isang mole is 6.022 times 10 to the power of 23. So since grams yung given, you have to get first the equivalent mole. No? Kailangan na to ang equivalent mole niya before computing for the total number of atoms. So how do you get the number of moles? You have to get first the molecular weight of the given compound. These are just basic computation. How do you get the molecular weight? So that would be, i-add, di ba? You have to add the masses, the mass number of sodium, of oxygen, and hydrogen. All the atoms that comprises sodium hydroxide. That's the molecular weight. Okay? Sige, you try to compute. What's the atomic mass of sodium, oxygen, and hydrogen? Sige, give me the total molecular weight. Class, i-add lang. Sige, sodium has 23 ba? Oxygen has 16. 1. That is total of 40. So 40 grams per mole. Excuse me. So that's the molecular weight. That's the unit, di ba, kapag molecular weight. Grams per mole. Okay, 40 grams per mole. Now, given the molecular weight, you can now compute the N. Okay? You can now compute the mole given the 20 grams. I-substitute lang nimo. Grams na given sa denominator, sa numerator, then dun sa denominator is yung computed na molecular weight nyo. So you can now substitute. So yung mole N dito, based on the given, substitute ha, then you do the math. Try to compute. 20 grams of sodium hydroxide with its molecular weight, 40 grams per mole. So, ilan yung mole? Cancel out, may cancel out. So, you get the mole. Okay, very good. So, yan yung mole. Okay? For a 20 gram sodium hydroxide. But the question is, how many atoms? How many atoms are there in the molecule sodium hydroxide, which is 20 grams? You use this relationship. This, kumbaga, conversion factor. Murag mo ni siya mong gamiton nga. Conversion factor. Sabi dito, in every 1 mole, there are 6.022 times 10 to the power of 23 atoms. So, parang ganito yung gagawin nyo. So, 0.5 moles, in every 1 mole daw, ilan ulit ang Avogadro's constant? 6.022 para ma-cancel out yung mga units. 10 to the power of 23. What's your answer? You try to compute it sa scientific calculator. Okay, correct. That is 3.01 times 10 to the power of 23. That's it. That's the Avogadro's number or the total number of atoms for the given compound sodium hydroxide with a mass of 20 grams. Kumbaga, more siya conversion factor. In every 1 mole, please always take note that the Avogadro's constant is 6.022 times 10 to the power of 23. In some computation, dili mass yung given. Diretso na mole ang given. So kung mole na ang given, madali na lang. Diretso na ninyo ratio and proportion. Diba? Kung moles na ha ang given, diretso na. Cancel out na siya diretso. In every 1 mole, you have this value to get the total number of atoms of that entity. Okay, so take note of that mole relationship. Sige. Okay, let's move forward on the types of inorganic reaction. Okay, so there are actually four types of inorganic, that is reaction ha, not compounds, types of inorganic reactions. So we have synthesis, decomposition, single displacement, double displacement. Yung neutralization and precipitation, it falls under double displacement na concept. Okay? And combustion naman, which is an organic type of chemical reaction, it falls under decomposition. Okay, sige, let's recall what's the concept for each type of inorganic chemical reaction. Okay, before that, kindly take note that the first 3 are considered redox reaction. So you know, no problem with that term. It involves reduction and oxidation type of reaction. Yung reaction number 1 to 3. Okay, so what happens during synthesis? Synthesis, synonymous terms niya, by the way, it's also known as combination, direct union. Combination, direct union. Okay, so what happens? You are just combining simple substances to form one product. One product lang sa synthesis. Example, A plus B forming AB. So look at the product side. You are just forming one stable product. Okay? Next, decomposition. Sa decomposition, yung other synonymous term niya is analysis, chemical degradation, chemical breakdown. So, nag-decompose, exact opposite of synthesis. Okay, so example, baliktarin natin yung reaction na nasa taas, AB. You decompose that, break it down into 2 simpler substance, A plus B. So that's decomposition. Exact opposite of synthesis. I've mentioned that combustion is under decomposition. So let's recall about combustion. Combustion, it happens in 2 possible types. Meron tayong complete combustion. Ayan, complete combustion. There's also incomplete combustion. So when it is complete, when it is incomplete. By the way, ang combustion, it's a general knowledge na it occurs among organic compounds, particularly among hydrocarbons. Kapag rich in hydrocarbons, ang compound, then it is prone to combustion type of reaction. So a good example would be the simplest organic compound, methane. So if methane makes use, no, in the reaction, if it makes use oxygen along the process, then that's a combustion type of reaction. When it is complete combustion, if sufficient yung amount ng oxygen, if enough yung oxygen supply in the reaction, then all the carbon present in that compound will be burned. Kaya walang traces of carbon, itim-itim sa product side. Kasi lahat ng carbon nasunog, that's complete combustion. Kasi enough, sufficient yung oxygen supply. Kapag naman yung oxygen supply is poor supply of oxygen, then that makes it incomplete combustion. That's why on the product side, we are observing carbon traces, or we call it soot, no? Mga carbon soot. And instead of carbon dioxide, yung mabubuo na gas, we tend to form carbon monoxide. So in replacement of carbon dioxide, we form carbon monoxide plus carbon soot. And of course, water is also part of the product. So that's the difference between incomplete at saka complete combustion. The supply of oxygen matters for combustion to occur. Okay, so dito ha, this happens, this product is formed, yung may carbon traces, may mga itim-itim, this is due to poor supply of oxygen. Okay? Sige. So that's it for decomposition. Next, single displacement. Sa single displacement, you have one element. One element, let's say, element X. Let me change the color. Element X, it will displace or replace one element from a compound. Example, a compound is AB. It will try to displace one element, and that is, let's say, letter A na element, making A as the single element this time on the product side, and in replacement sa position ng A, you have now XB. Okay? Or, possible din na sa single displacement, yung single element will try to replace element B. Okay? Making B as the single element on the product side, and the other product would now be AX. Okay? So later, I will give example how this happens. When will a single element displace A? When will a single element displace B? Okay? Sige. So that's single displacement. Sige. Okay, before na lang we proceed to double displacement, let's have the proceeding slide. You are seeing here reactivity series. Now, this reactivity series tells us the level of reactivity of metals and also non-metals. Kumbaga, the reactivity comparable to hydrogen. This will help you be guided if a single replacement reaction will proceed. Okay, you have to know this or be guided with this reactivity series for you to predict products in a single displacement reaction. So how will you know if single replacement will proceed? You just check if this single element is more reactive ba? If it is more reactive than the element that it tries to displace or replace. Now, aluminum is a metal. Diba? This is a metal. So in this compound, this is, yan. In this compound underlined with color blue, that composes positive ion and negative ion. Example, sa water. How is water formed? Diba? It comes from hydrogen ion and hydroxide ion. That's why you form H2O. Okay? So for a single replacement to occur, dapat yung single element na to, aluminum, should be more reactive than the cation portion of water. Yan yung i-displace niya, yung cation portion, knowing that metal tend to form cation. Yung kapareha lang niya na characteristic, yung kaya niyang i-displace, of course. Ang metal, i-displace niya, cation. Cation to cation, anion to anion. Okay? So ang question is, aluminum more reactive than hydrogen for the reaction to occur? You try to refer to this reactivity series. Going up, increasing yung reactivity. So meaning to say, this is the most reactive metal. Yung sa baba, least reactive metal. So my question, can aluminum displace hydrogen in the reaction? Yes or no? Given this reactivity series. Yes, because aluminum is written on top of hydrogen. So it can displace, making hydrogen as a single element. Okay, it is now displaced, sinipa siya. And of course, the stable form of hydrogen in nature is as diatom. Diba? Remember, ang hydrogen gas in nature, it is stable as diatomic molecule. So, H2 dapat. Pagkasulat sa equation, may subscript of 2. And what's the other product? That's aluminum hydroxide. Okay, aluminum hydroxide. How do you know? How do you predict the product? Again ha, in replacement, displacement man ni siya, replacing, di ba? Sinipa niya yung hydrogen. In replacement of hydrogen dyan, ito, yung underlined. Okay. Ayan, yung nasa taas, yung underlined na hydrogen, it will now be replaced with aluminum. You extract the ion form of aluminum. Aluminum is Al3+. Then hydroxide is negative. So crisscross method, you produce aluminum hydroxide as one product. Okay? So that's how you predict single displacement products. Okay, next, proceed to the second example. Lead. Lead is a metal ulit. As a single element, it will try to replace the metal portion of magnesium chloride. So the metal portion of magnesium chloride is the magnesium. But the question here, can lead replace magnesium? Yes or no? Can lead replace magnesium? Yes or no? Okay, very good. No. So no reaction. Just write it, no reaction. Sige, proceed. Zinc is a metal ulit. Zinc is a metal. It is reacted to cupric sulfate. As a metal, it will displace copper. And obviously, zinc is more reactive than copper. Okay, so it can displace copper. Any metals in nature, listen, in nature, any metals, they are stable as monoatom. Monoatom, meaning you don't have to write subscript. Unlike gases. Ang mga gases kasi in nature, diatomic sila in nature. In the environment, stable sila as diatom. So ang mga metals naman, stable na sila as monoatom. So just write it, the elemental symbol of copper. So pag sipa niya sa copper, replacement dyan is zinc. Zinc ion is Zn2+. Then followed by sulfate. So crisscross method. Ayan. So the other product is zinc sulfate. You simplify. Cancel out. No? Simplify the numerical charges. You'll get 1. Value of 1. Subscript of 1 is not anymore written. And last, you're seeing here a single element or an element that occurs as diatomic molecule. So it's an element. Only that it occurs as molecule, diatom. So non-metal naman ito. So kapag non-metal naman yung single element, it will replace the non-metal portion of the ionic compound, sodium bromide. So sisipain niya dyan ang bromine. And possible, kasi chlorine is more reactive than bromine. Okay? So bromine is now the single element on the product side. Okay. And in replacement of bromine in sodium bromide, you now have chloride on that portion, diba? Na plus chloride ion, crisscross method, you will produce this compound, sodium chloride. So that's all about single displacement. So you make use of this reactivity series. Sige. And then the last type of inorganic reaction is double displacement. So you have here general chemical equation. Let's say, wala na yung space, no? Dito na lang sa baba. In double displacement, you are actually reacting compounds to compounds. So you have example, compound AB reacting it to compound CD. So what happens here, you just have to switch, let's say, the cations. You switch the position of cations. As you switch the cation's position, you are at the same time simultaneously switching their anions. So the possible products would be C, B, and A, D. You switch, no, the cation. Okay, so as you switch the cation again, na-switch na rin ang anion. So that's what happens in double displacement, or also known as metathesis. Metathesis or exchange. Okay, so those are the synonymous name of this type of reaction. And I've mentioned specific examples of double displacement are neutralization and precipitation. In neutralization, you are simply reacting acids and base. So example, you react sodium hydroxide. Sodium hydroxide is a base. You react that with a strong acid, hydrochloric acid. So any neutralization reaction, it will form one product water, and then the other product is the salt equivalent from the reacted acids and base. So here, the salt equivalent formed as one of the product would be sodium chloride. You simply switch the ions. It makes use of the concept double displacement. For precipitation, same thing, it makes use of the concept double displacement, but this time, ang distinction niya sa neutralization is formation of precipitate. Okay, so a good example of a precipitation type of reaction is if you react the solution silver nitrate with a solution of sodium chloride, it will form a white precipitate, silver chloride. And then this aqueous solution of sodium nitrate. So this is an example of precipitation type of reaction. If a precipitate is formed, then that's precipitation. The point here is they fall under double displacement type of reaction, switching of ions. Try to observe the underlined, let me highlight na lang. Silver and sodium. Look at the arrangement. Nag-switch lang sila. I-switch mo lang yung ions. You can focus on the cations. As you switch the position of the cations, you are also switching the anions. Then you form the products for that double displacement. Okay, so these are the four types of inorganic reactions: synthesis, decomposition, single displacement, and double displacement. Okay, sige. And so we're done. We're done with type of reactions. Sige, we'll proceed with quantum numbers. Ang quantum numbers class, this was the concept proposed by Erwin Schrödinger. Okay? Ayan. yung quantum mechanical model, wherein he described that electrons, they move around i- through an electron clouds. Yung clouds na yan, he was actually referring to atomic orbitals. And yun na nga, we have set of quantum numbers that describes atomic orbitals or the distribution of electrons in the atomic orbitals. Particularly, yung first three, 1, 2, 3 quantum numbers, they described about atomic orbitals, okay, or the electron distribution. Whereas the fourth quantum number, it has nothing to do with atomic orbital. It only describes the behavior of electron. Okay? So these are the four. Let's recall the four quantum numbers: principal, azimuthal or angular momentum, magnetic quantum number, and then magnetic spin. Okay? So i-recall ha, recall natin. Ang principal quantum number, it has a symbol, small letter n. Its importance are, it describes the main energy level, the size of the electron, particularly the size of the atom, the distance of the electron from the nucleus. Okay? And how do you predict the n value? N value, that refers, simply refer to the period number of element. Period number of the element. Example, in the periodic table. The n value of aluminum. What's the n value of aluminum? You just have to check at what period aluminum resides. So it is found at period 3. So that's the n value of aluminum, of the atom aluminum. It describes the energy level, the size of the atom as well, even the distance of the electron from the nucleus. And this could have any value from 1, 2, 3, so on and so forth. So positive integer only. Positive integer. Pag positive integer, hindi kasali yung zero, no fraction, no decimals. Okay, so that's the importance of principal quantum number. What else? The relationship of the value ng n to this 3 directly proportional. Meaning to say, if higher yung n value ng atom na yan, the greater the n value, then we could tell it has also greater energy level. Greater energy level, and therefore the size of the atom is larger. Okay, larger size. And what happens to the distance of the electron from the nucleus? Kapag larger, lumalaki yung size ng atom, malayo. Malayo ngayon yung mga electrons from the nucleus. So farther yung location ng electrons from nucleus. Okay? So that's the relationship between the n value towards the following. Okay? Next, azimuthal or angular momentum quantum number, or this is designated with italic letter L. Its importance, shape. Kindly highlight shape. Okay? Now, the L value, that could be from 0, ayan, from 0 to n minus 1. So meaning to say, it is the n value that limits, that dictates L value. Example, sa aluminum, diba? I've mentioned its N value is 3. How will you get the L value? That would be from 0 to N minus 1. 3 minus 1. That's 2. So mula sa 0 hanggang sa 2. So 0, 1, and 2. These are the possible L values. And in every L values, there is a designated letters which describes shape. of the orbital. Okay, so kindly recall, if L is 0, if L is 1, 2, and 3, the letters designated for each are, okay, if L is 0S, 1P, 2D, 3F. Take note where these letters come from: sharp, principal, diffuse, fundamental. The point here is each L value, yes, it has designated letters, SPDF, and these letters describes a shape. Diba? Let's recall the shape of the S sublevel. Diba? It is spherical. It has spherical shape. Ang P, it has clover. Dumbbell. Sorry. It's dumbbell shape. And D, clover leaf-like shape. Leaf-like shape. And then, ito namang yung F subshell, yung shape niya is perpendicular with one another. With one another. Okay. Ayan. So, that's the importance of second, quantum number, angular momentum, azimuthal. Okay? Sige, third. Magnetic quantum number, designated with small letter M, that is actually small letter M, then subscript nga italic L. Okay, yung importance naman niya, orientation of orbital in space. Okay, orientation. Yung three-dimensional orientation of atomic orbital. And what's the possible values ng M sub L? Okay, take note, di ba meron siyang subscript na italic L. So meaning it is the L that dictates or that limits M sub L. You need the value of L to identify quantum number 3, the third quantum number. So example, let us continue yung sa aluminum na given. If N is 3, di ba, the L values are 0, 1, and 2. What are the M sub L values? Okay. Ang M sub L values, that is from negative L, 0 to positive L. And again, their importance is orientation. Okay? So, for 0, if the given L is 0, wala namang positive at saka negative portion. Di ba yung 0? So, simply write 0. Okay? If L is 1, then that's the time. It has a negative portion, which is negative 1, 0, positive 1. If L is 2, then that's negative 2, negative 1, 0, positive 1, positive 2. So that's how you determine magnetic quantum number orientation. Another importance of magnetic quantum number is it describes the number of orbitals in the subshell. Okay? Actually, the total number of M sub L values that you got, that's also equivalent to the number of orbitals per subshell. Number of orbitals per subshell. Okay? So example, when you say if L is 0, the letter designation, diba, is S. Okay? In S sublevel or S subshell, how many orbitals are there? You can make use of the values in M sub L. You just have to count the total number of M sub L values that you got. That's also equivalent to the number of orbitals in that given subshell. So you simply count how many digits or value you got. There's only one. You count it. That's one value. Next, if L is P, di ba, kapag L if L is 1, the sub-level is P. How many orbitals are there in P subshell? You count. 1, 2, 3. There are 3 M sub L values that you got. So you write it 3. Okay? And then for L is, if L is 2, that's D sub-level. Di rin lang nakusulat, D sub-level. How many orbitals are there in D sub-level? 1, 2, 3, 4, 5. There are 5. Okay, based sa M sub L values that you got. Okay, so kumbaga, if the orbitals are in a form of box, isa lang yung orbital sa S, any S sublevel. Kapag P sublevel, merong tatlong orbitals. Kapag mga D sublevel, merong limang orbitals, limang orbitals. Per orbital, di ba dalawa lang yung maka-occupy na electrons? Dalawa yung maka-occupy na electrons per orbital. So you can now compute maximum electrons that they can hold per subshell. Kaya nga kapag S, ilan yung electrons nga kaya niyang i-hold? Dalawa lang, 2 electrons. Kapag mga P subshell, ilan ba yung kaya ng P subshell? 6. And then kapag mga D subshell, kaya niyang i-hold na electrons, total of 10. 2, 4, 6, 8, 10. Okay, so that's the importance of the first three quantum numbers: principal, azimuthal, and magnetic quantum number. And last, yung magnetic spin naman, designated with small letter M sub S, it tells us the behavior of electron, the orientation of electron when it occupies an orbital. So dalawa lang yung orientation ng electron occupying an orbital. Yung isa counterclockwise yung spin, yung isa naman clockwise yung spin. So they should have opposite spin. That is based on Pauli's exclusion principle. No two electrons can have the same quantum number at least. They differ in spin. They differ on spin. So that's Pauli's exclusion principle. So yung isa will have value of positive half, the other one negative half. That is just to indicate that the two electrons here occupying an orbital should have opposite orientation. Okay? Sige. So these are the quantum numbers. First 3 describes atomic orbital or the distribution of electron. The last quantum number, it only tells about the spin, behavior of electron. Okay? Sige. So I'll just finish until this slide. Quantum number theories. Okay. You are familiar with this 3. Number 2, 3, 4. So no problem with that. Kindly add another quantum theory is by Heisenberg's uncertainty principle. It says that it is impossible. It is uncertain to determine both the exact position and the momentum of a particle. So Pauli's exclusion principle, no two electrons in an atom can have the same set of quantum numbers, at least they should differ on spin. Afbo principle, this is also the building up or the fill up. Fill up of electrons from lowest energy level first. So when you say lowest energy orbital first, so that would be 1s first, followed by 2s, then 2p, 3s, 3p, 4s, so on and so forth. I have taught you how to write this based on Afbo principle. Sa first column, sulat kayo 1, 2, 3, 4, 5, puro S. The second column, 2, 3, 4, 5, puro P. On the third column, puro D naman. Okay? And then on the fourth column, puro F. Okay? And then draw a diagonal arrow down to the left so that you will know the order. Okay? Ayan, the order which comes first in filling up electrons in the atomic orbital. So that would be a 1s first. You have to follow the arrow from the arrow tail to arrowhead. So 1s first, followed by 2s, arrow tail, 2p, followed by 3s, then 3p, followed by 4s, 3d, 4p, so on and so forth. 5s, ayan. You don't need to memorize, no? Para madali na lang yung pag-write ng electronic configuration of an atom. So that's all about Bow principle. There is an order that you need to follow from lowest energy level first. Then as you go up, you are increasing the energy orbital. So filling up. It's filling up, building up. That's Bow principle. Then lastly, Hund's rule. This applies to those sublevels with more than one orbital. So that includes P, D, and F. Remember, these are the sublevels with more than one orbital. Diba? Sa P, it has 3 orbitals. Sa D, it has 5 orbitals. F, it has 7 orbitals. So Hund's rule only applies to those subshells with more than one orbitals, wherein we have to distribute first the electrons singly on the same direction before pairing them up. Example, for the atom oxygen, there are 8 electrons, diba? For a neutral atom of oxygen. So how will you fill up the electrons in the designated orbitals for the atom oxygen? So 1s first, diba? Followed by 2s, then 2p. Okay? So let us fill in the 8 electrons. 1, 2, 3, 4. In filling up electrons for a p sublevel, dapat yung mga electrons in parallel spins first, or meaning to say, i-distribute sila singly before they are paired. So, 4 na yung na-distribute, 1, 2, 3, 4, kulang pa ng 4 to make it 8, total of 8. So, singly first, 1, 2, 3. Tsaka mo i-pair up, 4. Okay, so that's how you apply Hund's rule. That's the concept related to Hund's rule. Okay, so these are the quantum theories which helps you be guided how you distribute electrons in their designated orbitals. Okay.